Please have out on your desk right now two things. One of them is your homework from last night. The other that you're going to have out on your desk is your note packet, open to where we left off, which is going to be on page 11 at the top. So go through, please, hand those in, have your homework out and notes out, and open takes from the other day. Thank you. Now, we have a lot that we need to go through and cover, but as long as all of the assessments are in, we'll start looking at what we should have had for the last one. This was someone's from last year. Hands up, please, and tell me what you need to do in number one in order to rationalize that expression. We got 1, 2 of us, 3, 4, 5. Hopefully this was easy. We told you that this is what's coming for you. What do you want to say? We need to multiply the numerator and the denominator by the conjugate, which is going to be the same thing with the sign in the middle change. 2 plus root 11 over 2 plus root 11. When you do that, you multiply the numerator by 1, so it's 2 plus root 11. Then down in the denominator, we have two binomials multiplied together. So when we do that, I list that out over to the side. 2 times 2 gives you 4. The outside and inside terms give you positive 2 and negative 2 root 11. And then at the end, you've got minus 11, which leaves you with a negative 7. Some people are going, well, wait a minute, that's not a choice. And they're right. I hate leaving the negative down in the denominator, so we either assign it to the numerator or put it out in front and assign it to the fraction as a whole. Questions on that one? Next one up. Should have been, we need to find what our conjugate's going to be here. Hands up, please, if you can tell me what that conjugate would be. 3 plus root 2 over 3 plus root 2. So we get something like this. Now, when we're doing this, some people are saying, well, this is the answer that my Algebra got me, and I didn't see that there. Hands up, please, if you can tell me why you wouldn't see this ever as a final answer. Divide everything that's there by 7, so it's 3, 1, and 1, so 3 plus 1 root 2 over 1. Again, notice, this was so terrific because the foiling is done over to the side. You don't want that right next to the work that you're doing. Same thing happens with number 3. We can continue this out. Now, here's where we start getting some interesting things to happen. Hopefully, we're able to do this in our head by now. Because if you're not, we don't know our number facts as strongly as we need to. Hands up when you can tell me the biggest perfect square that goes into 12. We got 6 of you, 7. 4 times what? 3. And so it's 4 times the square root of 4 times 3. What about 48? What's the biggest perfect square that goes into that? 3, 4, 5 of us. Oh, come on. Come on. 16 times? Well, there you go. So once I get to here, I'm going to start taking some square roots. The square root of 4 is 2. Square root of 16 is going to be 4. It's 4 times and 2 times, so we would have 8 roots of 3 and 12 roots of 3 added together, and you've got 20 roots of 3. The next one up, I think, was just more square roots. Was that right? This one's square roots? Yeah. That's what that one comes out to be. Your biggest perfect squares are 9, 4, and 16. And you would go through and take those square roots. I'm more interested in seeing if you're able to transition down. 3 was different than what you've done so far. How is 3 different than what you did? Or sorry, how is 6 different than the other 2 that were there? Why is the third one different than the first 2 with the simplifying radicals? Perfect cube. Whole new number set. Who can tell me the perfect cube that goes into 24? Who can tell me the perfect cube that goes into 375? 125. So again, I would do the breakdowns, and as I get them, these are the breakdowns that we get, and that's what leads us to our answers. If you're not where you need to be, that's all right, but we need to make sure that you get where you need to be. So that means if you struggle, stop in. We'll go through and get you on the right path. But we do need to see it if you're not being successful. And we need to make sure that when you're doing the work, that the questions, that the work that you're doing is actual and on task and appropriate. These are the answers. Did I give you these the other day? Yeah, were there ones that we wanted to see? The big one, at least from the other sections, was 46, and I'm wholly okay with seeing that. Yeah. Can you tell? I'm sorry, you said I couldn't do which ones? 33. All right. So we're going to look and we'll do these two. Is there one more we want to see? Yes. 34. Are these all roughly the same type? I think so, maybe. So I'm going to bounce over and look at 33, 34. Yeah. So when I look at 33, I mean, I see some stuff when I'm doing 33. I'll say this, though. It was kind of funny. When I did it with the first grouping, I did it my way. And somebody goes, well, wait a minute. I found a faster way. My way took less up. So there's more than one way that you can do this. I see 33. I'm going to carry this over. And I'm going to start this off by taking it over one single root. Because I see a reduction that can happen. What reduction or what would reduce away if I put these two radicands over each other? Hands up, please, if you can tell me. There should be a reduction, and you should be quick enough to go through and see it. What do you want to say? The x's are going to get gone. So, and there's actually more. I'm sorry, I stopped it. Yeah. The y squared. So this is going to be the square root of 3xy squared all over 5xy cubed. Now to get here, again, hopefully we've done a terrific job, and this is going to reduce out. This is going to reduce out and leave me with just a y in the denominator. So now I'm going to split it back up. Up top in the numerator, I've got it, root 3. Down in the denominator, I've got, what's left down there, 5 and a y. Is that right? Yeah. Okay. Now, the problem is there's a radical there. I need to find the smallest perfect square that 5y goes into. Hands up, please, if you can tell me the smallest perfect square that 5y goes into. I've got 1, 2, 3 of you, 4, 5. Oh, come on. Wow. Smallest perfect square that 5y is going to go into. What do you want to say?
25y squared, its own.
25y squared. So what do I need to multiply this by? What ugly one will I use if I want the denominator to become 25y squared? See? Radical 5y. So we'll do root 5y over root 5y. And some good stuff is going to start to happen. When I multiply across in the numerator, hands up please if you can tell me what I would get. What would I get when I multiply those two numerators together? We've got no people. Like it's in the coma. Eva B, what do you think? Root 15y. Now I'm going to tell you, you don't even need to write that part out. She's correct. It's the square root of 25y squared, which is going to be what? Nope. No. What's the square root of 25y squared? 5y. That's how we got there. There's more than one way that you can go about getting there. Now, let's take a look, please, at the next one. Did we say 34 also, or no? Yeah. These guys are all in the same family, so let's just do 34 then. Looking at 34, I'll drop this down. Again, I look at it and see, if I were to combine them under one radical, would any reductions occur? Yes or no? Yes? So if I do that, Gerard, tell us what's going to reduce out. Or I'll say this, let me write it out, and then you tell me what reductions I can do once I finish. So 2x squared y cubed. So what reductions can I do?
The x squared in the bottom.
Denominator.
Yeah, in the denominator, and then we'd be left with x squared at the bottom.
Which is called the numerator. Okay.
We'd factor out the y in the numerator and be left with y squared on the denominator.
So now my fraction has reduced down to 5x squared all over the 2y squared. Is that right? And all of a sudden when I'm looking at this, before I go forward, I should see there's more I want to do with that. And there's more than one way that we can go forward. But I'm looking at this right now. Something is aching to be done on this. Who sees what you want to do? So what's that going to be when you take the square root of x squared? And what's the square root of y squared? And it's in the denominator. So now I've got that, and I'm going to make it, now I'm going to split this up into two fractions. I mean, even we could do this. wouldn't you leave that as the final answer? What's the problem with what I currently have down? 4 of you, 5. Sam? What's wrong with that right now? What do I have, and what's in the radicand position of that radical? 2. What's the smallest perfect square that 2 goes into? No? Not that goes into it, it's 4. So what do I need to multiply this whole expression by in order to get my answer? The ugly one I'm going to use is root 2 over root 2. If I do that, multiply going across up top, Aaron O, what do you think you're going to have when you multiply going across? X root 10. And what about in the denominator? What would you be left with? Careful. 2. There you go. Okay? Now, you could have taken a bunch of different paths to get there. You could have initially kept that separated, multiply everything by what would make the original be a perfect square, and take the square root. Whatever you choose to do, there's multiple paths to get there, but you have to be able to get there somehow. I'm a big fan of reducing and working with simple numbers along the way because I hate having to bounce over to the calculator all the time. Now, let's take a look. Go forward, please. We left off on day 11 in your notes packet. So let's go over and take a look there, please. And was that, I'll ask you this, was it beneficial to have the answers to the homework last night?
Yeah.
Okay, then remind me at the end of the period. I'll give you the same thing for your homework for tonight. If the value that we're working with, if the index is even, then when you take the root, it's going to be only the positive value. If the question requires you, if you're given the root, it's only the positive or principal value. If you take the root, you get 2. And I'll show you the difference. If you have the square root of 25, that's equal only to 5. The negative of the square root of 25 would be a negative 5. If you have the equation x squared equals 25, then x would be equal to plus or minus 5. Easy way to remember, see how that's a squared? The highest exponent or degree of an equation lets you know the number of answers you're going to have. That's when it's plus or minus. Questions on that? That's a really tough concept. And you all seem to be struggling with when it's plus or minus. The reason being, you're not viewing it as an answer to an equation. If this is what you're given, and it's simply to simplify, it's whatever the sign of the radical is. But if you get the square root from solving an equation, if it's x squared equals something, then you're going to be getting 2 answers. And by the way, if you didn't already, are you allowed to sign in? Yeah, sign into your calculators if you haven't already, because we're going to do a bunch of stuff and we're going to show you something really cool about them in a minute. Here's our first question. Over on the side, you can go through and list out your procedures or steps for solving it, because the algorithm for doing this, or the repeated steps, it's the same every single time, no matter how complicated they are. So the first thing that I would want to do, Felix, what would be your first step in solving for the x in this equation? So I'm going to subtract the 2 from both sides. So now I've got the square root of 2x plus 1 is equal to 3. So your first step is to isolate your radical. So we did that. What's the next step going to be? Jordan, what do you think?
Square both sides.
Terrific. You don't square root both sides, you square both sides. So that leaves me with 2x plus 1 is going to be equal to 9. From here, we would simply go through and solve that remaining equation. Angela, what would you do to solve this out? What would your next step be? Let's subtract a 1 from both sides. So I've got 2x is equal to 8. From here, what would you do next? Let's see. Deanna, what do you say? And you get what as an answer? Now, with square root equations, you always need to be on the lookout. You cannot, as of today, take the square root of a negative number. You need to check your answer to see if it works. Now, please let's not get this well, we'll show you and then we'll go over the conditions of using this. Everyone go to your calculator now. Please make sure you've signed in. If you haven't, we're missing 1, 2 of you, 3 of you. Sign in if you haven't. What we're going to need you to do is go to your home screen and then you're going to get a new document going. So you press 1 to get a new document. The next thing that you're going to do, don't save what's in there. We're going to do a calculator-based document. So, add calculator. You're going to type in what the original expression, or original equation is, which was the square root of the quantity 2x plus 1. And then outside of that, you're going to add 2. And then equals 5. Now, you're not going to press anything just yet. Your first step is to input the equation. Your second step is to go through and tell the calculator to evaluate it out at a certain value. The truth of this statement. You're going to press Control and then equals. And a bar is going to be an option. Go and select that vertical bar. And then you're going to tell the calculator to evaluate this out at x equals, what answer did we get? Was it 4? Okay, so you're going to type in x equals 4. And now you're going to hit enter. The calculator is going to tell you whether the statement you just entered was true or false. Now, when you do this, you can go back. The algebra dictates that you got this as an answer, and you're going to indicate it is in fact an answer by going through and circling or putting a box around it. One thing, this is, again, understand the Regents exam, this is why I'm so flummoxed by how low those Regents scores were across the board. Like, we're talking profoundly low. Mid-70s for Enriched as a class average is horrid. We're going to say this to you nicely. Guess and check by no means is math-based. We went through and said that the other day. It is not math. You don't get credit for it. The Regents exam does permit it. And on a multiple choice question, you can judge the validity of the answer choices after you've done it algebraically. You can simply take the answers and plug them in using that. Say, here's my equation, here's the answer selections, do these work? Absolutely. They let you use it. So we'll go over that in June. You use it to check your answers now. If there's not justifying algebra on the questions that you're doing, you aren't getting points, period. And don't tell me, well, I knew what this was. Imagine if you go into you're on trial for murder, and your lawyer gets up and he goes, look at him. He's innocent, you can tell. Just look at him. Because that's what you're giving me on your assessment sometimes. There's no justifying algebra to give me the answer you got. You have to show the justification. If that's not there, and I'll show you all of the calculator gimmicks in June to make it so even if you get stumped, you can check whether or not your answer is correct. That's why people go through it easily. Again, that's why out of those scores, the lowest grades that you saw, the lowest I think was in the high 70s. The lowest. Not class average. Class average was an 88. And even that's low. We'll show you the gimmicks, but that's not math. And you, again, you guys aren't going here, you're here to become engineers. Now, there's no alternate procedure. Some of the process is the same every time. Our first step is to always isolate the radical and then work to solve the remaining equation. Do the algebra you can. Get that radical gone. Look at question number 2. Hands up, please, if you can tell me what your first step is going to be in number 2. Hands up, please, if you can tell me what your first step is going to be in 2. Terrific. We've got 5, 6 of you. Oh, come on. I have faith that there's more of you. If I subtract 1 from both sides, I've got x minus 1 is equal to the square root of the quantity x plus 11. What would my second step be? Caleb, what do you think? Now, this is where it gets awkward. And again, some of us that just got these charity passes previously, this is going to be a time when you really need to make sure you pay attention to what's going on, because you're going to make a common algebra mistake. The right side of this is so easy. The right side of this, I'm now left with an x plus 11. The problem is this here. What do I need to write out in order to get the correct answer on the left-hand side?
Write it out both times.
You're so good. You're so good. X minus 11, oh sorry, minus 1, times x minus 1. That's exactly what you need to do. List it out in the margin. Now, hopefully maybe some of us are breaking free of the magic rectangle of this function. And you're starting to know first, outer, inner, and last. Hands up, please, when you can tell me what the trinomial you're left with on the left-hand side is going to be. We've got 4 people. You scored a goal the other day at soccer, is that right? Did you win the whole game because of you? Did anybody say thank you? I should say more than thank you. Stephen, what's that going to be when you expand it out?
X minus 2, x squared minus 2x plus 1.
X squared minus 2x plus 1. Now, this is the part where the lack of work last year might hinder you slightly, and only in the beginning. But understand, what type of equation am I left with now? Hands up, please, if you can tell me. What type of equation am I staring at? Quadratic. How'd you know it was quadratic?
An x squared.
It's got an x squared. Hands up, please, and tell me how we solve most, we'll say this, some quadratics. Set it equal to 0. What's the next thing we do once we get everything messed up on one side? We try to factor. Does everything in life factor down? No, the second one we get to today is not going to either. So I'm going to set this equal to 0. I want my term here positive, so minus x minus 11. This is starting to look great. We've got equals 0 over here. What trinomial is on the left-hand side, McKenna?
X squared minus 3x.
Minus 10. Outstanding. Does that factor? Well, there's no GCF. It's not a difference of perfect squares. It's got a leading coefficient of 1. Do I have numbers that multiply to negative 10 and add to negative 3? Hands up, please, when you can tell me if you crack the code and what this will factor down to be. I've got 3, 4 of you. 5. You think they're going to know? All right, you believe. Let's see. Jordan? What numbers multiply to negative 10 and add to negative 3? What are your numbers that multiply?
I got it now.
What? What?
Negative 5 and positive 2.
So what are your factors going to be?
X minus 5
And?
and x plus 2.
Now, this is something that apparently over at Spry they let you all get away with. You do not go to the answers now. You need to show a middle step. You know? Okay, what are you going to write when you do the t? Because I think I know what you're talking about.
Plus 5, wait, x minus 5 equals 0, right?
Okay, and
And then x plus 2 equals 0.
it's called
I remember.
It's called a zero product property. What that means is your answer has to be equal to 0. If the left is equal to 0, the whole product is. If the right is equal to 0, the whole product is. Now, here's another thing that you were told allegedly, and I'll take it as allegedly. Some people sit there and apparently came in with the impression that you always reject the negative. That is absolutely, unequivocally, 1,000,000 billion% wrong. I will give you questions on tests specifically designed to get that out of your head. You will get a positive and negative answer, and the negative answer will work, and the positive one will not. We'll give you questions on tests and quizzes where you're going to get 2 negative answers, and they're both going to work. We're going to do questions where you get 2 positive answers, and neither one will work. You check every single individual answer. What?
I solved it.
You can do that as well. Now, when we do this out, once you get to here, let's see if the answers are true. How can you go through and do that? You become a little robot. Go over to your calculators and you're going to input the original. And you're going to plug in a 5. So let's do that quickly. Careful. You got to go back and change. Oh, was that an x equals to start? Oh, I'm sorry. And then root x plus 11. Now get out of that. Do the bar. Arrow over, do the bar. And now you're going to tell it to evaluate the truth of the statement when x is equal to two different values. Our first one is 5. You're going to hit enter. Does 5 work? Sure. Arrow back up and reselect it, because you don't need to re-enter the whole thing. Arrow up twice, and while that's highlighted in blue, you hit enter. Oh, you may have to go down and then bounce up again to get it. Hit enter. There you go. Change that. Now, was our answer -3 or -2? -2. Check the -2. So the -2 doesn't work. That's called, and we're going to use a big kid word here, an extraneous solution. You circle the answer that works. You write reject, not omit, underneath the ones that don't. Now, you have to check every answer that you get, period. Questions on that? Now, some of these are going to be very awkward. Hands up, please, if you can tell me why this question looks like it just might be a little bit awkward. We got 1, 2. If you play it out a little bit, you'll see why. What about it? There's 2 radicals, so what we're going to do is we call it balancing out the equation. The first thing that you would go through and do is you're going to give the more complicated radical alone. So I look at the 2 radicands. One's a radical x. The other's the square root of the quantity x plus 5. I'm going to get the more complicated one by itself. So I'm going to subtract the root x over. Now our process is going to be the same. You're going to see this is going to look really nice on one side and look like a traffic accident on the other. But we can go through and handle it. What would my next step be, Maddie, once I get to here? You isolated the radical. What's the second step? And you've got to remember, you got to do both sides. So now I'm going to go through and I'm going to square both sides. So when we do that, I go through and have the quantity of x plus 5 is equal to, now I'm going to take this out over on the right-hand side. And I'm going to write out 5 minus radical x times 5 minus radical x. You have to FOIL this out. First, outer, inner, last, combine like terms. Go through and do that right now. You are very, very capable. The algebra that you're doing right now is absolutely appropriate and right where you need to be. First, outer, inner, last. Tell me what you get. We'll wait for 8 of you that can tell me what this would be when we simplify. We got 1, thank you. 2, thank you. 3, 4, 5 of us. Come on. We can get there. 6. 7. 'What are you going to get when you multiply your first terms together?
5.
Careful. Radical x squared, which is just x. Now, can this simplify down? Sure. Think, what would this simplify down to be? Okay. Keep going. Close. Plus x. Now, I still have a radical in the equation. So what's my job going to be to solve it? Well, the next step is to get the radical alone. So what am I going to have to do, Giacomo, to get the radical alone? So that's going to leave me with, now this right-hand side is kind of easy, -10 root x. What is going to be left on the left-hand side? Michael, what do you say?
-20.
Just the -20. These reduce out, and you're left with -20. What would we do from here? There's 2 ways you could get your answer, and either one is more right than the other. Cece, what would you do from here? You want to get that second radical alone. So? Sure. Let's divide both sides by -10. There are some, and you're not wrong if you want to square both sides now, but the numbers get bigger. That reduces away. Here I'm left with 2 is equal to radical x. Keep going, Cece. What would you do next? And what are you going to be left with? Terrific. Now, before I put a box around that answer, I need to make sure it in fact is the answer. So let's please have you go into your calculators and plug that in. There's 2 radicals you're going to have to square twice. That's why it's such a terrific question. You might think you might have a quadratic, but it's not. It's linear both times. Let's check the validity of what we have. Oh, we got to do x equals 4. In the beginning, this is such a powerful tool, especially for you to bridge that gap from, those mid-70 scores up to a mid-80, mid to high 80s. Just knowing how to use your technology. Is that value true or false? Looks like it's true. So I'm going to go through and select that as my final answer. Questions on that? Yes.
When you're like simplifying or getting the radical or negative 10 radical x by itself the first time, would you just added radical 10x to the left side and then subtracted the 5 and gotten 10 radical x at this point?
You could have brought this over here, but then you would have had to subtract the x and the 5 over.
Yeah.
Yeah. But that's moving everything around. It doesn't matter. Either way, you're going to get there. Okay? Now, this next question, we're going to bounce over to number 5. It's probably the toughest one we're going to do today, and then we're going to follow it up with one that looks really tough and is actually really, really easy. Take a look at this question. Hands up, please, and tell me what your first step you think would be in number 5. We got 1, 2, 3 of us, 4. We're getting there. We're getting there. What do we think our first step would be? What do you want to say? I'm going to subtract x. I want to get that by itself. So what am I going to do next from here? I'm left now with this expression. Hands up, please, if you can tell me, and I am going to correct you if you're wrong. Hands up, please, if you can tell me what you would do from here to proceed forward. Close. Yeah, cube both sides. You've got to pay attention. If you said square root, you are wrong. Or square, because squaring does not remove it. It makes actually it way more complicated. So we're going to cube both sides. And again, let's please not make any lazy Larry algebra mistakes on this. Hands up when you can tell me what I get when I take the quantity 2x and cube it. Terrific. You got to remember to cube the 2 as well. So we get to this part, right? Now the next thing that we're going to do, this is starting to look like this. Who's got a read on what you might want to try from here? What would you do? Be a problem solver. What are you going to try? I'll keep that there. So if I kept this here, what else would move? Let's subtract the x squared and minus 2x. This kind of looks like it's a quadratic equation, and our approach to it's going to be the same. I get 0 equals 8x cubed minus x squared minus 2x. Now, how many answers is this question going to have? 3. You know we've got enough tools at our disposal to get 3 answers now. Don't fall asleep at the wheel as we're doing this. Taking a look at what's there, I normally say, well, my first step is to look for a GCF. Does this have a GCF? Take out the x. Watch what happens. And this is going to get more complicated. You have to get over it because we're not going to do the questions that work out nice and easy all the time. I take out an x. I'm left with 8x cubed. X times 8x squared minus x minus 2. I'm to this point now. So we get here. After we factored last time, well, we'll say this. As of right now, this has 2 factors. I'm going to go through and write this out, and I'm going to take each of my factors and set them both equal to 0. So I take the GCF, set it equals 0. Does x equal 0? Yes. That's our first answer. Now I go over here, and I've got 8x squared minus x minus 2 is equal to 0. Now, and that's why all of this garbage that I'm finding out that they did with the like, you don't need to show that middle step when you set the factors equal to 0. You absolutely do. Now, once I get to here, I'm going to ask myself, does this factor down? Here's a way to check. Because normally we try it by guess and check, and I know you all hate factoring to begin with. You especially hate guess and check, and you especially hate it when it's not easy. Multiply your outside coefficients, and some of us don't understand what a coefficient is. A coefficient is just a number, not a number and a variable. Hands up, please, and tell me what I get when I multiply my outside coefficients. What is my inside coefficient? Are there numbers that multiply to negative 16 and add to negative 1? If there are, it factors. If not, it doesn't. Are there numbers that multiply to negative 16 and add to negative 1? And notice, I'm not going to be some schmuck who's going to sit here and tell you everything factors. Life doesn't factor all the time. Okay? Get over it. So does this factor down? No. Does anybody recall, and it's okay if you don't, what you have to do to solve a quadratic that doesn't factor down nice and easy? Did you have Miss Shahada? Who had Miss Shahada? She make you sing this song? All right. See, here we go. Here's your quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, you need to know what that formula is. I'm sorry, you have my profound apologies for the land of lollipops and gumdrops that you were living in before, where you weren't encountering quads constantly, but we live in a quadratic environment. What you need to understand is, if you don't know it now, just make sure you do. What is the A value for this question? Hands up, please, if you can tell me. We got 1, 2, 3 of you. 4. Please, what do I say? Terrific. What's the B value going to be? Hands up for that. Kevin? Negative 1. What about our C value? Now, you need to know those values. Again, and some people tell you to show more garbage than you need to. I'm not going to do that to you. It turns people off the mess. Go, why do I have to show this out? You're right, you don't. I don't even need you to show the formula. I need you to know the formula. I don't need you to show it. What I need you to do is give this, and I did it so many times. I generated an image for it, so I didn't have to keep writing it out all the time. We've got 3 values I need to fill in. One's in yellow, one's in green, and one's in blue. 2 of the values are real easy to figure out. Who can tell me one value that I can fill in that's super easy to fill out that I don't need a calculator to do? Jordan?
In the yellow area, that's where the negative 1 would go.
Careful.
It would turn to positive 1.
So this is a positive 1. Who can give me another value I'm going to go through and fill in? Which is? Terrific. Terrific. Now let's look at that green value. So let's go to your calculator. I don't need you to write it out. I need you to plug it in. I need you to type it out. Go into the calculator, please. Put parentheses. Put your B value in it, and then outside of it, square it. So parentheses and the parentheses, negative 1 squared. Oh. Careful. I think this is wrong right now. Is that right? I don't have the numbers. Whomever this is, make sure we change that. Our inside value should be a negative 1. B squared, that's terrific, minus 4 times our A value, which is, was it 8 in this one? Our C, was it 2 or something like that? Negative 2, all right. And you're going to hit enter. And by the way, I know I'm touching on stuff you haven't done yet. This, though, you actually do know this value. This is called, right now, this is called the radicand. And in a quadratic formula, did they tell you what this is called? Discriminant? Have you heard that word before or no? Okay, a discriminant is a specific type of radicand that you find. Now, how many answers does square root of 65 simplify down? I know. Because it's b squared minus 4ac, not plus it. Now, looking at that, do any perfect squares go into 65?
Other than 1?
Yeah.
Nothing besides 1 does. What I need you to do is, how many answers total did we say this question was going to have?
3.
3. Right here, you found your first answer. How many answers did you get here? 2. What I need you to do, go back to the original. And let's plug the original in. And you see why we get asked the right questions for the Regents exam. This would be so great to throw on as the last question. Go into your calculators, please, right now. Plug in the original question. Plug in the original question. The cube root, by the way, if you need it, is control caret equals, what was it, 2x? 3x, all right, then put the bar. Now, we're going to check our first answer. Nice, easy, x equals 0. Is that going to be true or false? Fabulous. Now, go back up, select it again. If you arrow up twice, it should be highlighted, and then you can hit enter on it, or I think you can hit control enter. I'm not 100%. Yep. And now, we're going to change it. Our second answer, do control division, and let's do in the numerator. Is it, what was our numerator? Was it -1 or 1? 1 plus root 65, because it didn't simplify down, over, what's our denominator, 16? 16, and hit enter. That should be true. Now, go back up. You've only checked 2 out of the 3. Highlight again. The only thing you need to change is the negative. Don't, oh, you did too much. Control division, and you have to retype it. Or you can just edit it so the negative is gone. So, control division, 1 minus root 65. We had 3 candidates for answers, and how many did we get? There you go. So they all work. I put a box around them. Here's your last one. Don't give up on us, because this is hilarious. This question, somebody goes, oh my God. And you're right. This is the easiest one we've done all day. You can tell me what your first step's going to be. What?
Come on.
No. You said square root it? Square it. So I'm going to square both sides. We've got 1 plus the square root of 2 plus the square root of x is equal to 9. Hands up, please, if you can tell me what we're going to do from here. McKenna? Subtract 1, so I've got the square root of 2 plus the square root of x is equal to 8. Hands up, please, if you can tell me what happens next. Yes. We're going to square both sides. So I've got 2 plus the square root of x is equal to 64. From here, I'm going to subtract the 2. And I get radical x is equal to 62. What answer am I going to get for x? Hands up, please, if you can tell me. Yes. Check the answer. Does it work? I'll tell you right now it does. Congratulations. We finished on time with just about a moment to spare. Now, was that question hard? It was the easiest one we did all day. Now, let's do this, please. You all are rich. We did 2, 3 today, so here is. If you want the answers to the homework, if this loads on time, feel free. Here are the answers. Some of the questions are difficult. Do as much as you need to. You've got to be ready to go.
We had the homework in.
Nope. This is always the awkward part when it feels like your head is in the way. Can you move your head?
No, baseball.
Have a great weekend.
No, that's not why.